Hello, and welcome to the 10-minute guide to CATIA sheet metal design. The objective is to provide a very quick overview of the CATIA V5 sheet metal design product that allows the design of sheet metal parts in a very intuitive and productive environment. The target audience for today's session is the existing CATIA version 5 customer base, whether you currently use the CATIA Classic portfolio or CATIA PLM Express. If we do our job correctly, we hope and expect this will provide a nice overview and that you'll contact us if you have any questions or if you would like any additional information. The power and value propositions associated with CATIA sheet metal design is far more than what can be conveyed in 10 minutes, but this should provide a nice introduction and overview for you and your colleagues. Let's move on. As an engineer, you need to design sheet metal components while respecting company standards, material standards, standard design parameters, standards for manufacturing and tooling, and standard design rules. So it's not just about designing a part, it's about being able to take into account sheet metal specifications and manufacturing constraints early in the design phase to avoid errors and manufacturing issues. You need a solution to accelerate your innovation and ensure manufacturability, as well as to reduce design errors, to improve the quality of your part, to save time on repetitive tasks, and to focus on the part specifications. You'll need to collaborate with your team, other people in your company, and even suppliers or contractors. So you need to be able to generate, reuse, and modify standard formats for design, such as STEP and IGES, and also for manufacturing, such as DXF. The CATIA sheet metal solution is a specialized application, delivering a full set of process-oriented features for advanced sheet metal design. It's a dedicated environment to manage design and manufacturing standards, material standards, and design rules. Manufacturing constraints are taken automatically into account early in the design phase to reduce design errors and save time in production. This reduces costs across the full product lifecycle. It delivers unique capabilities, allowing you to work concurrently on the folded and unfolded state of the part, fully respecting the part and the assembly specifications. It delivers specific functionality to facilitate collaboration and improve performance on complex parts. In a moment, we'll see a short demonstration highlighting some of the key capabilities within the CATIA V5 sheet metal design product. You'll see that CATIA sheet metal design's feature-based approach uses industry-specific terminology for sheet metal workbenches and features such as walls, flanges, cutouts, stamps, extrusions, bends, etc. This allows sheet metal specialists to design sheet metal parts using a language they understand in creating feature-based sheet metal designs. It is also important to understand that CATIA sheet metal design offers the same ease of use and user interface consistency with the other CATIA V5 applications. This drastically reduces training cycle time while unleashing the designer's creativity. It should be noted that CATIA sheet metal design can benefit from the power of the CATIA KnowledgeWare product family. All sheet metal specifications can be captured to build, manage, and reuse the corporate knowledge of the company and thus increase the quality of the design, while at the same time reducing time to market. In our demo, we'll see several examples where formulas can be used which allow the user to utilize predefined values that represent company standards. You'll also see in the CATIA model structure a file for sheet metal parameters that allows the user to define or specify the default sheet metal parameters. Let's begin the demonstration. We'll start with a profile and we'll do a wall definition for the first wall. We'll then define a flange with a specified length, angle, and bend radius. We then create a second flange and specify the appropriate limits through the use of predefined planes. Next, we create a cutout on the flange using a cutout profile to trim the flange and create the desired pattern. Then we create another flange. We then do another cutout based upon a specified profile and apply some rounded corners on the new flange. Then we create a flanged hole on the new flange by specifying the appropriate parameters within the pop-up window. This is a predefined feature containing the specific parameters needed to define a flanged hole. To create the same flanged hole using CATIA part design would require several features, where a CATIA sheet metal flanged hole is simply one intelligent feature. Next, we do a wall-on-edge definition using the specified parameters, and we see the preview capability. Pay attention to the bend definition and the valuable capability to define the bend extremity relief for this tab. We see how easy and seamless it is to toggle between the folded and unfolded views of our sheet metal part, which is a very strong value proposition of CATIA sheet metal design. Using the mirroring capability, we instantaneously define the other side of the sheet metal part. And again, we view the folded and unfolded representation of the part. We then create another flange using some profiles to define the limits, and then another cutout area using two more profiles to generate the precise flange shape that we want. We use a series of profiles to quickly and easily create several cutouts on our part. From within one of the cutouts, we create a custom user flange driven by a user-defined profile. Then we create another wall-on-edge through the use of a specified profile and the definition of the specified values in the pop-up window. We do a quick view of the folded and unfolded representation of the part and then smooth some of the corners by applying a small radius. We then define a surface stamp using the provided parameters along with an embedded user-defined profile, and then apply a second and third surface stamp before doing a final view of the folded and unfolded representations of the sheet metal part. You'll also notice that it provides a preview of the final part. In this brief demonstration of CATIA sheet metal design, we saw some of the key features that provide very strong value to our customers. In addition, there are many other features that were not shown in the interest of time. It is also very important to know that deformation of the material during the folding and unfolding process is managed through access to company-defined bend tables that includes the definition of bend radius, allowance, and sheet thickness, as well as stamping tools tables. This allows the user to verify the design compliance with the company-defined standards and to ensure the design quality. Using the CATIA generative drafting product, designers can also extract documents in DXF format for such downstream applications as nesting and cutting. Finally, it is worth noting that your V5 data is always accessible in V6 and the 3D Experience platform. CATIA V5-6 sheet metal design can be obtained in one of three ways. The first option is to buy CATIA Sheet Metal Design 2, or SMD, within the CATIA V5 Classic portfolio as an add-on or shareable product. In this manner, it can be added to any existing CATIA V5 configuration or shared across multiple configurations. The second option is to buy CATIA Fabricated Product Creation, or FPE, within the CATIA V5 PLM Express portfolio as an add-on product. In this manner, it can be added to any existing CATIA V5 PLM Express CAT configuration. FPE includes both CATIA sheet metal design and CATIA weld design. And the third option is to buy CATIA Flexible PCB Design, or CBE, within the CATIA V5 PLM Express portfolio as an add-on or shareable product. In this manner, it can be added to any existing CATIA V5 PLM Express CAT configuration or shared across multiple CAT configurations. CBE includes both CATIA sheet metal design and CATIA circuit board design. So what have we seen? In the detailed design phase, we've seen how you can create right first-time sheet metal parts thanks to design in context of the virtual product. And in the manufacturing preparation phase, we've seen automatic flattening views created directly from the 3D design part. In addition, the part manufacturing view encloses manufacturer specifications derived from the engineering specifications. So in conclusion, we've seen how CATIA sheet metal design allows the fast and efficient design of sheet metal complex parts. We've seen how easy it is to apply company-defined standards to ensure design quality. And we've seen how we can take into account manufacturability constraints early in the design phase and speed up assembly design. CATIA sheet metal design is highly applicable to and heavily used across multiple industries. These include automotive and aerospace, high-tech and electronics, electrical, industrial equipment such as construction equipment, agricultural machinery, and railroad, and consumer goods such as furniture, white goods, electronic goods, and other domains. In short, any company who designs and manufactures sheet metal parts such as supports, brackets, housings, structures, body panels, joining parts, and so on. If you're in one of these industries and/or manufacture these types of parts, CATIA sheet metal design may be the right solution for you. We thank you for your time to view this short video, and we would ask you to contact us if you have any questions or would like any additional information. Thank you.